So I'm Florin Balus. I am in charge of product management at Nuage Networks. And we're going to go through a number of demos in this section. Okay? So when you look at networking for the data center, people are saying proprietary hardware is needed, otherwise the network will not perform. We're going to show you that actually, if you have the right brain, the networking hardware can function with existing off-the-shelf chipset and in an open ecosystem. And then there are people saying SDN doesn't scale. So there are some issues. There were some issues in the initial phases with SDN testing. There were issues with flows, with throughput, with basically the capability to converge fast. We're going to talk about scalability. We are going to demo to you how fast we are bringing up the networking between multiple compute nodes. And basically, people are saying, oh, you know, SDN and virtualization, does it natively support any workload? So we are going to show you how we can actually support multiple workloads, including containers in their natural environment, not on VMs. There is no need to put them on VMs to provide basically networking and scale infrastructure connectivity. That's what they were designed for. At last but not at least, SDN and applications, there is a big gap between them. We'll show you how we fill the gap. Okay? That's the focus of the next few demos that we're going to show. So I just wanted to introduce the first part. So our idea right from the beginning was that we're very good at networking. We can provide the top networking and policy layer. We have the expertise. So there was no innovation happening in the networking domain for the last 7 years. One was the last big startup that was done successfully. And we wanted to enable hardware networking vendors to be successful at starting new companies, give them the brain and the feature-rich software-defined networking solution. So basically, the main issue people had was with how complicated were the overlay gateways. Okay? You needed gateways to go from the network virtualization domain north-south and to the bare metal server. So I'm going to cover briefly the use case for gateways, right? So when you want to go to the internet or into the VPN, you need a gateway, a set of gateway racks actually, and you have to put here software gateways to translate basically between the network virtualization and the regular IP. So basically, in that case, you do need to put VLANs to interconnect to routers. So this is indeed a big pain, right? Because you really don't get rid of VLANs. You still have to handle the VLANs between server-based software gateway and the router. And I know a customer that started SDN 2 years ago who actually has a bunch of racks in there and it's becoming a nightmare. So I do agree this is a problem. Now, the other use case is to implement gateway on the top of the rack to connect bare metal servers, non-virtualized environment, into the network virtualization solution. And in our case with Nuage, from the beginning, by design, we do not need a software gateway to go north-south, to go to the internet. We are talking router language, and we use router encapsulation. Standard RFC 4797, interoperable, everybody implements it. Probably about 4 years ago, we did the interoperability testing in the networking world. And when it comes to the top of the rack, that's where you need, indeed, you need a gateway. So we wanted to be able to help the hardware networking vendors to actually do the gateway function easily and at scale. So we have a number of gateway options. This is what we presented last year. Basically, we implemented a software gateway ourselves. Wherever you have a small data center, up to 10 gig needs to go to the bare metal server, you can use one server and is running our software gateway, is redundant, all good. Now, if you have a large number of bare metal server and a large data center, then we implemented initially ourselves a 1 terabit gateway. And I'm going to talk about the 1 terabit Nuage Networks gateway in the next slide. Now, this year, we took actually steps to integrate with third-party hardware vendors, okay? And we are customer-driven, so we actually are running those integrations for customers, and we are driven by customers in these integrations. We actually had about 5-6 hardware networking vendors that we are considering, and we are moving towards integrating with all of them openly. And basically, I'm going to talk about who we are going to demo. We are going to demo two of them working together to show you how basically we designed to actually be able to interconnect, give the customer the choice to put any kind of hardware networking vendors. So our terabit gateway, it's a 1RU gateway, has basically 96 10 gig or a combination of gig, 40 gig and 10 gig. And the main thing with this gateway is it's basically off-the-shelf chipset. I know that people are saying with off-the-shelf chipset you don't get layer 3 networking. Well, we figured out how to do layer 2 and layer 3 service networking, network virtualization. This is not IP underlay or anything like that. We did implement on our gateway full layer 2 and layer 3 networking. And this is running SROS, Service Router Operating System. And basically, when it comes to physical to virtual connectivity, this is kind of the high-level demo we plan to show. This is the use case, right? People have virtualized servers, different type of hypervisors, ESXi and KVM, and then they have bare metal servers. And we are going to show you two types of gateway vendors integrated with each other. So our controllers will provide the networking intelligence to go between the non-virtualized and virtualized world, and also interconnect between data center domains, okay? So what do we have? What did we implement to support this type of deployment? We added to our virtualized service directory what we call gateway console. It's a gateway console that allows us to either discover the gateway as it gets deployed in the network, or actually generate the gateway configuration from a template. And then basically we have a picture of what the gateway has available, ports, VLANs for the networking admin. Then we allow him to specify IT-friendly names for the attachments. So I can say this is the web server 1000, or this is the branch interconnectivity, right? And we gave them the possibility to take the gateway and chop it in terms of resources and how they are allocated. So basically you want to have security for colo or for enterprise to say, this is for development, these are servers for development, these are servers for production network. Okay? So this is basically permission system that we have in the console to actually allocate for any gateway resources, and then those resources are exposed to the end users. The end users don't see the port, the VLAN, they just see, okay, that's my server 1, and I can deploy on server 1 web services. He can make that decision based on this view, and he can attach it to service design, okay, that Dimitri is going to show. So think about that topology that I was showing at the beginning. You can attach in their virtual machine or bare metal servers or containers. So how does it work? So basically, this is our VSD, the controller, and you have here basically the agents deploying the hypervisors, right? And let's say we have here a third-party gateway. I'm not going to say the vendor name because I still want to be a surprise when we go to the next one. He kind of blew the surprise. We wanted to keep you guys until we start the demo. I will tell you about what we are going to do. But okay, so here basically we have the third-party gateway, bare metal servers. So as soon as you want the VSC, the controller, to take over configuration of the gateway, we establish basically a connectivity to a local agent in the gateway. And automatically, the gateway resources get discovered here in the VSD. Then we have the capability to allow the network admin to assign resources to groups, right? You don't want the production team to take over a development server, right? So they can do that, and then they can map servers to service design. I want the server to be behind the firewall, be part of a certain subnet. And then basically, as soon as we do that, there will be a push from the policy to the controller, and the controller will program basically into the gateway, it will program the service, the required service parameters. Moreover, basically, the controller will populate in here all the VXLAN configuration. So we'll say this particular port that has the production server 10 is connected to the service topology that has layer 2, layer 3, layer 4. And basically, it will connect that bare metal server to virtual machines. Moreover, the controller can also extend that connectivity across data center domains because it's part of a federation. So for many gateway vendors, they just started with, like local VXLAN, for example. We are extending that to be across data centers, okay, through our controller. So our plan is to actually really allow them to add capabilities in the hardware and not worry about the control plane part. We really want to open up, allow them to migrate from basic VXLAN to layer 3, to ACLs, to whatever they want to do in the data path, without having to worry how do I do that across domains, without worrying about how do I program the virtualized world, whether it is containers or hypervisors. And oh shoot. Okay, so basically what we are going to show you is these two hardware vendors. We are going to show you an integration we have with Arista and another integration we have with HP, and we are going to show them working together. So the topology basically will have a virtualized side, we'll have our 7850 VSG, and then Arista and HP. And what we are going to show...
Good question, actually.
Okay.
For OpenStack deployments, is Neutron communicating to the controller or to the VSD?
To the controller, yeah, to the VSD, yeah, to the VSD at the top. Yeah, and they don't need to put the plugins from them. We are taking care of all of that. Right? But very good question. So basically, we are going to show layer 3 services spanning virtualized and non-virtualized world, right? And then between Arista and HP and the virtualized world, we are going to show layer 2 virtual network. And do you want to move to the other side? You want to bring up this one here?
Yeah, that's what I'm going to.
And for OpenStack, are you guys using the native DNS mask agent for IP address management, or do you have that built into the controller?
No, we actually let OpenStack do IP address management.
Yeah, and we're just getting the IP addresses and answering the DSCP, or we have the possibility to place the DSCP in the underlay if they don't have like a DSCP, an IPAM module that talks with OpenStack. So we've been through a number of deployment scenarios and got hit by different type of deployment issues, challenges. I think Sunil mentioned about 60 trials. Like we are talking about trials that took at least 1 week, some of them a month. We probably had over 100 engagements, like demos, and it was very good experience talking to customers.
What were the biggest problems that you found in those deployments?
The biggest problem, I think it was, the networking part was actually doable. We had, in general, not too many features. We had enough features to address the networking part. I think it's about the integration with the upper layer, right? Making use of our REST APIs, right? Originally, I think we came up with networking primitives, subnet, routing domain, ACLs, and I think people that were trying to integrate the networking guys understood it, but the application developers, they had to figure out how to take a 3-tier application and map it to those network primitives. And I think that's what we are addressing with the application designer. I shouldn't like take his thumb there.
Let's start with the gateway a little bit to illustrate what we're going to do here. So first I'm going to show this part on the left. So we actually have an OpenStack deployment that it's a pretty simple OpenStack. It actually, interestingly enough, it runs on top of ESXi, so it's OpenStack with ESXi, just to make it a little bit more interesting, because everybody does OpenStack with KVM. So we have a basic OpenStack implementation here, and in the network, there is a couple of networks here. I have created a layer 2 network, I call it there, it's called the VTEP subnet, and there is the 2 routed networks that are attached to the router. I have this VTEP router here that creates a layer 3 network, so it connects a couple of subnets together. And right now I'm running two instances here. You will see in OpenStack I'm running one instance in the layer 2 network and one instance in the layer 3 network, right? That's all standard OpenStack stuff, but I wanted to explain that they are being used there. So now, this is the Nuage VSD, the user interface, and what I'm going to show you is a little bit the process of onboarding a gateway, making available, using a gateway, interconnecting a gateway. So what happens is that as soon as a gateway comes up, and I'm going to go here, as soon as a gateway comes up, it shows up down there on this corner as a pending gateway, right? So this is not a gateway under management. I have a couple of gateways here that are already under management by VSD, but there is one gateway that I just brought up and it's under management. So in order to get this gateway under management, the only thing I have to do is come here and push this button, and now my gateway is under management, and just to remember it, I'm going to give it a name and say it's VSD. So now, what happens is the moment the gateway comes under management, obviously we discover all the interfaces of the gateway, and we know exactly that there is this list of interfaces, and what I have here, I have to go to my notes to see which one I'm going to use, 115. So if I go here and I pick interface 115, not 15.5, what I can do now is I can grab an interface and I can give this interface virtually to a user or to an organization, right? Because a gateway is something that the infrastructure operator is managing, and I'm going to let essentially end users to be able to activate services in this gateway on demand without me being in the picture, right? So the way I do that is I add the permission here. So I go and add the permission. I'm going to give this permission to this OpenStack enterprise. And I'm going to say, okay, this enterprise can manage this gateway. And also I'm going to create a VLAN on this gateway. And the guys tell me that the thing behind connected here is on VLAN 20. And this is my physical server. It's connected on this gateway on VLAN 20. So I have created my gateway, and that's it. I'm done now, right? I have created a VLAN on the gateway, and that's it. So now, how do I activate the service on my gateway, right? So here is my OpenStack demo installation. And I told you that I have a layer 3 router. This is the VTEP router that I just showed you in OpenStack a couple of seconds ago. So I have the VTEP router, in the Nuage components, actually, we have these concepts of a domain. A domain is essentially a large layer 3 virtual network. A domain is split into zones. Zones are there mainly for policy, and every zone can have multiple subnets. So a subnet is what you know, it's a subnet. And so you will see here I have this VTEP router that has one zone and has two routed domains here, right? And two subnets there. And these subnets were created by OpenStack through our plugin. They are all auto-created. But what I'm going to do here is, in order to attach my gateway, I'm going to attach a vPort to the subnet now. And I'm going to say, by the way, I want to use the VSG interface, is 115, the only one available to me. I want to use this VLAN, and I'm going to create a port. And there you have it now. I have a port connected in my virtual network that is actually the physical port of the gateway, right? Just by doing this attachment.
So this is our gateway, the 7850 1 terabit gateway, right?
And then I'm going to activate this port, and let me write the name that this is the VSG port. So essentially, just by this simple drag and drop, what I did is I got a port of a physical gateway and a specific VLAN, and I attached this to a virtual network and a specific VXLAN ID that is all managed in the background by the system, right? The only thing I had to do is drag and drop the port into the system. And now I have the connectivity, and I can actually go into a host that I have sitting behind here. I'm going to try to go to a host that I'm sitting behind here, and I'm going to try to create, ping the VM there and do the famous ping and make sure that my connectivity works. In order to do that, I have my hosts as virtual machines to do my life easier. So I have this host is behind VSG. It says this is essentially the host that I have behind my gateway, connected to VLAN 20. And I need to go back to my OpenStack thing, or my VSG thing. I need to see what's the IP address of this guy. So it says 10.1.1.4 here. I need to come back. Come on. Oh, come on. Okay, and I can do the famous ping, and hopefully it's going to work, right? So what I have done here is I have attached the gateway. This host is sitting behind the gateway as a VLAN, and I showed the connectivity. And if you notice now, this host is actually doing a layer 3 function. The interface here has an IP address 15.15.15.100. The VM is sitting on a different subnet. So you get the distributed layer 2 and layer 3 with hardware VTEPs working and operating like that. Now, what I'm going to do next is, and very briefly, is you saw that I have another couple of gateways. I have an Arista gateway here, and I have all the interfaces of the Arista gateway here as well, and I have an HP gateway over here as well. And I'm going to go back to my design. I'm going to go to my layer 2 domain now, essentially my layer 2 subnet. And very similarly, I'm going to grab a vPort bridge, and I'm going to say I want to connect the Arista Ethernet 1 interface, and this is VLAN 21. And I'm going to create my port and interface, my bridge interface here, and let's call this Arista. And then I'm going to add the second bridge port here. I'm going to pick my HP gateway here.
So you're demoing Arista and HP. Are you guys going to expand to others? Is there going to be a compatibility list?
That's absolutely the idea. We're just showing you the full integration with HP and Arista. And of course, our own hardware VSG that you just saw Dimitri show you, where we did demo both layer 2 and layer 3 functionality simultaneously. And now with Arista and HP, we're going to do the layer 2.
What specific OVSDB schema are you guys using?
We're using the standard OVSDB schema, whatever is published. Okay.
For hardware VTEP.
For hardware VTEP, right? The latest is version 5 or.
So the one Ben wrote.
Yeah, that's the one that is published out there on GitHub.
There is definitely discussion about adding like ACLs in there,
right,
and support for other functions.
So the trick is, this is very basic, like it's just layer 2. And that's what we are demonstrating. The gateways just support layer 2 at this point. As the gateways come up with features, we'll support whatever other feature is needed. The key here is that what we want to show you, and the reason we showed you first our gateway, is because our gateway is layer 3 as well. In our gateway, you see everything. In the partner gateways, you will start seeing these features as they are delivered in the hardware.
Oh, so have you already sort of started using a new schema that you guys created within your hardware?
Within our hardware, we use a proprietary way to communicate to our hardware. We actually use BGP.
Oh, right, that's right.
Our controller runs embedded in the hardware, and we use BGP. So we don't use OVSDB at all. But with other people's hardware, we are working with our partners to extend the schema both for layer 3. There are extensions for layer 3. We are extending more importantly for ACLs, for policies, for all this kind of stuff, and we're going to be able to push this as well. So
the good news is that you don't need proprietary hardware to do L3. As you can see, we have support for L3 in our VSG.
And you also shouldn't need proprietary protocols either. I mean, as we're seeing, these configuration management protocols are built to be extensible in an open way. I mean, if you guys did need additional functionality, absolutely no problem for you guys to build your own schema and publish it and just say, hey, here's what we did.
Yeah.
That's exactly what we're going to do.
That's what we plan to do. I think with partners, we plan to add extensions to OVSDB draft. And we could submit in that draft.
Your own schema, though. I mean, OVSDB is good enough. But like as we're seeing, you've got vendors coming in, they're saying, well, there's certain things that this schema should do. The protocol's fine, but since the schema is a separately defined thing, you guys could very easily define your own and publish it.
Right.
Yeah, that's the
So and then, I saw the famous ping here, obviously, right, between the gateways and stuff like that. We can geek out and I can go show you the CLIs of the gateways, but I'm not even going to attempt that because the bottom line is you see the reality, right? What is happening here is our support for gateways is gateway comes up, gets auto-discovered, we give permissions to the system, and then users, the only thing they have to do is drag and drop interfaces, and they get their activation going, right? So